Welcome to Software Engineering Daily. I'm your host for today's show, Joe Nash, and today I'm joined by James Lambert. James is a software engineer and the creator behind Portal 64, a demake of Valve's Portal for the Nintendo 64. Welcome to the show, James. How are you doing today?
Thank you. Thank you for having me. Yeah, I'm doing very well.
Awesome. So, we mentioned Portal 64 in that intro. We mentioned, of course, Nintendo 64, which might be a shock to some of our viewers because that is a console that's a fair bit in the past for many of us. I want to know, what is your journey to getting started developing for the Nintendo 64, and how did you come to start making a remake of Portal for the Nintendo 64?
Yeah. So, I grew up playing the Nintendo 64, and as a kid playing games on it, I wanted to make games.
Right.
I got really excited about that idea. And so going back to make games on the N64 just always it appealed to me. And I just was on the internet and noticed like, hey, there's people who are developing tools that you need to make N64 games, but using modern tools to run on the console now. So I wanted to give it a shot. So I started tinkering around with modern SDK, which is taking libultra, which is Nintendo's proprietary SDK, and running that using modern tools. So you can just use Linux to build and create these ROMs. And so I started tinkering with that. And the first big project I did was a Game Boy emulator that runs on N64. And that kind of just got my feet wet. And then they had a game jam for their first game jam for N64 games. So I joined that and had a lot of fun making a game, Telelocation Gemini, if you want to find that one. That had a lot of fun making that game. And since then, I've just been involved in making Nintendo 64 content. And every once in a while, I'd get an idea like, I wonder if this grow. I would try things out, and at one point, I'm like, I wonder if we could do portals, right? The portal effect, and I tried it out, and it worked, and got really excited. Like, I'm gonna see how far I can take this, and it just ended up going and getting a lot of momentum to the point where I was actually building out test chambers and building out the game to try to be as close as I can, but on N64 hardware.
Perfect. That's very cool. So there's a couple of questions I guess I wanted to ask off the back of that. So you mentioned that, along the way that you're using, this modern take on libultra, which is
Mhm.
Nintendo's SDK, and that you were doing that on Linux. Like, what does your developer environment look like? Like, what are you using in terms of, text editor? What's the process of
Right.
getting games onto, into a ROM and I guess onto the N64?
Yeah. So I just use VS Code,
Cool.
and there's no real other. I mean, you could pretty much use any IDE. The person who's maintaining modern SDK, they they made it so you can just install it using apt, if you're familiar with
Yeah.
with Ubuntu or I guess Debian based systems. You can just add to his repository. You just apt install modern SDK, which comes with some examples, and it sets up a build environment where then you can just from a make file say make, and it uses a version of GCC that targets the chip set or the architecture of the N64.
Mhm.
And so it's able to compile the code to object files or in the ELF format, and then you get the final bundle of code, and then you use a linker script to lay out the ROM layout. So that usually comes with, at the beginning you have to include headers for the N64. If you're familiar with the CIC chip, that's like their copy protection system. It adds headers for that for the console to read, and then after that comes the code segment that it lays it out, and the N64 when it boots will copy the first megabyte of data from the cartridge into the RAM to run the code. And then anything else after that, any assets you want to only be on the cartridge, and then you have to load those manually. And there's a specific address space that you use
Right.
when access. So you say, okay, I want to copy from this memory range to this memory range, and the different parts of the console are mapped to different memory ranges. So the cartridge has a certain range. You say I want to copy that to memory to
Yeah.
RAM, and so that's kind of how that works.
Fascinating. Very cool. You mentioned, getting involved with N64 because, you know, you had grown up with it and you wanted to make games for it back then and you found a way to do it as an adult. And you mentioned these game jams. Where does Portal come into it? Like, why did you decide to target Portal for this? Was that a game jam idea that kind of grew, or did it come from elsewhere?
Let's see. It's like I was experimenting with graphics techniques, so a few of them were like doing real time shadows in like a technique. I at least had never seen it in a game. Like you typically see the most advanced shadows you see on N64 games. They use shadow maps where they render the character from the perspective of the light, and then they just take that as an image and draw that image on the ground flat. So it really only works well with flat surfaces. I wanted to try out a technique that's similar to shadow volumes, where you render the volume where like the back of the volume of the shadow, and then you're able to render content that I'm not describing it very well, but that was one thing I did. And then another similar graphics tech, other interesting graphics techniques. I'm trying to think of other ones I was tinkering with, but I had these ideas, and I just wanted to see if it was possible to do the graphics, to do a Portal effect at all. It was
Yeah.
really like where it started out as, right? And I wasn't thinking I'd be making Portal, but then as I was thinking about, well, what do I want to do to showcase the abilities? Like, well, might as well make it look like Portal,
Yeah.
right? Because that's the most like famous game that has a Portal effect in it. And it was after seeing how well it actually ran that I was thinking you might actually be able to make the full game out of this. Like because really, like you think, okay, the Portal technique, it sounds like, oh yeah, that's really advanced. That's something N64 can't handle. But really, it's kind of like doing split screen, but the split screens overlap. And N64 games do split screen all the time. So I figured I would just see how far I could take it. And so I yeah, I grabbed I grabbed the assets from the PC game in order to start porting them and downsizing them. And this is a bit of a tangent,
Yeah.
but in the process of compiling the game, I didn't want to have to like create low res assets that I included with the project. I wanted it to be an automated process as much as possible. So things like images and sounds,
Yep.
they're not part of the repo. Instead, you need to if you want to build the game, you have to get this resources from Portal on PC, and it can extract the sound effects and then downsize them and recompress them to the format the N64 needs, and that's all done as part of the build process.
That's pretty cool. So I saw that, you know, when I went to play Portal 64 in the lead up to this chat, I saw that, you know, you shipped it as kind of an installer and you point it at your Portal installation. And I thought that was, you know, like a copyright hedge, right? Like making sure that the person owns the Portal assets so you're not distributing them. But so it's actually taking the assets that exist on, you know, my PC in this case and converting them into the low res format. That is very cool. And what does that process look like?
So if you're familiar with makefiles, that's what I used. And so makefile, what it does is it specifies an input file. So in this case, like the bundle of resources from Portal, and then you say take these input files, and this generates that output file. And then you can now say tell make this output file that doesn't exist that's derived from these inputs. You just say make that file, and then underneath that like dependency, you can declare the steps the computer needs to take to make that translation. And then you can even chain them together. So for example, Portal, the source files actually come in these pack files. They're a bundle of resources. And to make it easier to work with, I want to first extract all of those out into separate files. So the first step is, well, I want to get all the sounds extracted from that pack. So I have a make step that says to generate all of these files, take the bundle, and then run this. There's an open source project somebody made that can extract the files and extract all the files out. So now you have all the sound effects, but they're the full quality sound effects that are uncompressed. So then I have another make step that says, okay, now that I have that, I want to generate this specific file, and then it corresponds to that file in the Portal pack directory. So take that, run, I think it's called SOX. It's a audio utility on Linux that can manipulate audio files. I use that to resample it down to a lower sample rate for memory reasons, and then after that, I then use a tool that compresses the audio to the 80 PCM format that the N64 uses for its compressed audio.
Yeah.
So those are all separate steps that it runs in the make file, and it generates that output file of here's the audio. But then there's another step that will take all of the compressed audio files and then bundle them together into what's called a sound bank for the N64, which is just it's it has like a definition of here's all the sounds, but then the actual audio data, because it's so large, is actually streamed from the cartridge. It's not loaded into RAM ahead of time. So just the description of the audio is in RAM, and then you say, I want to play this sound effect. Here's where it lives in the cartridge, and the audio system will stream it from the cartridge as it plays.
Fascinating. Okay, very cool. I guess that brings me to a slightly tangential question, but like, what is in those cartridges, like computing capacity wise? So obviously there's memory of some kind, but like I know there's Nintendo cartridges over the years have had various capabilities in actually like in the cartridge. Like what is it device wise?
Right. So this is I don't know great detail, but I will say what I do know. So there is the CIC chip, which is their copy protection, and the way that works is the CIC chip, the N64 is able to communicate with that, and based on the content of the first megabyte of the ROM, it will go and read each byte, and then it will ask the CIC chip, okay, here's the data that is in the ROM, and after feeding it the data and doing a process, it's supposed to spit out a specific number at the end. And that number is also saved with the cartridge. And then the N64 hardware also has like a corresponding chip, so they do it in sync. And so when they get to the end of the process, it says, okay, does this number match? And if it doesn't match, then the N64 will actually do a hard reset and prevent the game from booting. So you have to get that CIC to match. So that's one piece of hardware. You have the ROM chip, and I know that in order to create aftermarket cartridges, they need to use an FPGA, which adds a little more complexity to just a basic ROM chip, because most ROM chips, it just works where the console sends out, here's the address I want to read, and then the chip just spits out the data at that address. But I know, I see, this is where I'm not certain.
No,
I
that's
think
fine.
N64, they made proprietary ROM chips that weren't just so simple. I'm assuming it was to make it harder to create copies, is the assumption. So that's there. These ROM chips, that there's probably something special about them. I don't know exactly what. But then, so you have that, the CIC, the ROM chip, and then you also can have save chips as well. So you have EEPROM, SRAM, and flash, and they're just different technologies for saving. Oddly enough, the EEPROM chip, if you use that, actually communicates, the console communicates with the EEPROM chip using the same bus that you use to communicate with the controllers.
Oh,
Not sure why they made that decision, but just to send a command to the cartridge to save with EEPROM, you actually go to like the controller bus and say, okay, save as if I'm talking to a controller, but instead it goes to the cartridge. I'm not sure why they do that. But the SRAM's much simpler. It's just there's a specific address that if you write to that address, it writes to the RAM, or if you read from that address, you're reading from that RAM, and that's battery backed. And then flash RAM, I think, is similar, but it's not battery backed, and there's different timing characteristics. You can't write nearly as fast to the flash RAM as you can to the just SRAM.
very cool. Thank you for breaking that down. Yeah, I'm always, I think when I first realized, playing as a kid, that like the save data was on the cartridge and not on the N64, I was like, what is going on in here? They're obviously having no idea about anything at that point. But yeah, I've always been curious. So, you mentioned this point where you decided like, hey, I may as well just make Portal. So for Portal 64, how much of Portal are we talking? How far did it get?
So before I took it down, I did manage to get out I got Proto First Slice done officially, which was the first 13 test chambers. And actually, you'll notice it's 13 test chambers, but when you get to the last test chamber, it says 12. That's because Portal, they start at test chamber 0, which I thought was a really clever joke, because programmers like to start our arrays at 0. And so having Gladys have test chamber 0 be the first was just really fitting. But yeah, the first 13 test chambers, which is right after you get the full portal gun. So you get the full portal gun in test chamber 11, and then in 12, you then get to do your first puzzle with both, where you have control over both portals. And then after that, the demo ends. I did manage, before I took the project down, I already had made progress on test chambers 13 and 14, and they were in kind of a incomplete state. They didn't look great, and there were a few little details I wanted to fix, but at that point I got the takedown, so I'm like, I'm just gonna release what I have. So if you're able to get the hold of the latest ROM, I think it's version 14, that will have those two test chambers as well, with some missing details in them.
Right.
But that's as far as I got. But within those test chambers, though, I was able to get, trying to think of like the list of features. Like I was sure to add, like details like the security cameras, and you can knock them off the wall. And if you do, Gladys has dialogue lines that she gives. I wanted to have like the little indicator lights on the floor, so when you push a button, they light up and show you like this is connected to that. And just I was getting to the point where I was trying to add small details and getting, instead of just having the game be functionally there, to actually start to feel like Portal and even be playable to somebody who's never played it before. Because I was realizing with those indicator lights, I was like, do I put them in? At least, early on, I wasn't sure if I was going to get there, but then I realized, well, if this is your first experience with Portal, Valve. I know they're really heavy with play testing, and so all these little details they added and things that they've done with these test chambers, I'm sure were there for very specific play testing reasons. So, like, I was trying to match as close as I could, so that way I would get the benefits that they discovered during that process when they were making the game.
That makes sense. And when you say you try to match it as close as you could, I guess a useful thing for our listeners at this point is to emphasize like what Portal 64 actually was, because it's not a port in the sense that you were able to take existing code and put it on there. Like this is, you were writing, you had no source engine. This was, a complete from scratch rewrite, right?
Right. Yep, that is correct. Yeah, and I think being able to do it as a complete rewrite meant that I was able to simplify a lot of the code in ways that so it could run on N64. Yeah, and I think I'm trying to think of like what. Well, for example, I did have to rebuild the levels from scratch. I wasn't able to take their level format and translate it automatically, so that actually was in the repo, copies of low poly versions of the levels. But I had to be much more. I had to cut details from some of the levels, or I had to do it in a way that was more efficient for the N64. So like if you're familiar with Hammer, which is their level editor, if you load up Portal in Hammer, you'll notice it's built out of a bunch of pieces. So like you'll have like this is a wall section, and then you can combine it with other wall sections. And so the level itself is built up of lots of little wall sections that all piece together. And instead of doing that, I just had like, well, this is an entire wall. That's one piece. And so it meant I had to do a lot more manual work of just building out the levels exactly what they look like in the final game. But I'd imagine that the reason why that they had it as modular pieces is a lot easier for their level designers to iterate on ideas, because they have this set of tools or pieces they could piece together the test chamber. And if they don't like something, they could go change it by adjusting and reusing pieces. So in that iteration process, that's super valuable. But for me, when I was just targeting a specific final product, I could just look at the test chamber and say, that's what it looks like, and build it out exactly what it looks like as the final result. And I was able to be more slim and precise and more efficient with my level creation, so that could actually run on N64 hardware.
Awesome. Yeah, I think you're right with that theory about Hammer. Actually, there was a like a big Twitter discourse going on recently about how like no level editors in any of the big engines have replicated Hammer's ease of iteration because of that kind of like object or brush based methodology. So yeah, I think the iteration speed is like notable. So obviously the other big thing about Portal as a game is the physics engine. And so I wanted to ask, first of all, I had an N64, but I was quite young. And I was looking back through my like memory of like, when I think of physics-based gameplay, I think the earliest game where I really think of something like that is another Valve game, and it's Half-Life 2. And I can't think of any game on the N64 that really depended on a physics engine in the way that like a Portal or other Valve games of that era did. Was there anything, was there a physics engine comparable to what you've built on the N64 in its time?
I don't know of any. With the physics engine, there was an open source project. I can't remember what it was called. I want to give them credit that I based my implementation on.
It was a physics engine for N64.
I'm blanking. It wasn't for N64. It was just an open source.
Oh, cool.
Physics engine for PC. It was, I want to say something Box. I don't think it's Box 3D. I know Box 2D is a 2D physics engine, but
if you figure out, we'll throw it in the show notes. If you're listening to this, check the show notes for that physics engine.
Okay. Yes. So that was I based mine on that. I actually the code for it's called contact resolution is pretty close, just their code. I just ported it to C.
Yeah.
But so collision response, which is just I guess like just a quick overview of how like a physics process works. So you have a bunch of movable objects. So I only implemented rigid bodies. So a rigid body is simulated as like a single point. So that one point has mass and it has velocity and angular velocity and moment of inertia, which is kind of like mass, but for rotation. So you have all those attributes on this single point, and that's pretty easy to simulate on its own if you're only applying forces and velocity to that, right? Like you have a pretty basic parabola trajectory for movement, for gravity. Like, every step you just say, okay, you have your velocity, add to the position the velocity times time, and then do the same with velocity to acceleration, and then you're able to get the motion pretty easily. So that's pretty simple to do. But then the difficult thing is you actually wanted to interact with things.
Sure.
And to do that, you have to do collision detection. And so that I wrote pretty much myself from scratch. In the collision detection, I have a video that goes into greater detail, but there is a technique called GJK and EPA, and those are just acronyms based on the names of the people who wrote these papers.
Very confused.
Not a super memorable name, but they basically describe a method of, you take two convex shapes and quickly being able to find if they overlap, and if they do, what vector can you use to separate them the fastest, which direction you should push them apart, basically. So those are very, very clever algorithms and very efficient, actually, for N64, because it's able to do what it does in very small amount of code and memory. So that's really efficient for the cache on the N64, which is very important because the N64's RAM is slow. So you have that part, and I use that to do what's called contact generation. So you have the point mass as rigid bodies. You put a shape around them, a convex shape, and then with that, you're able to collide it with other shapes to generate contact points. And then you take those contact points and you pass them into the contact resolver. And that's the contact resolver is the part that I didn't really write much myself from scratch. I based my implementation very heavily on that physics engine. But with all that together, you're able to simulate the physics system, because what the contact generation or what the contact resolution does is it takes that point rigid body and it says, okay, well, if you have this rigid body, but it's touching an object over here and they overlap this much, what force do I need to push on that object to get it to spin or move in a way that they separate? And that's the basic gist of it. And my system, I only generate one contact per frame, at most one contact per frame per collision. And then I just keep the contacts around until I can tell that they've separated apart. And that single point generation per frame was what let me kind of get away with getting this to run on N64. Yeah. More complicated solutions that try to generate multiple contacts at once, like the physics engine is more stable and it works better, but it's more computation per frame. So
yeah, I guess that thinking back to, I mean, especially the bits you implemented, but the first Portal in general, the physics objects that are moving aside from the player is mostly the companion cube, right? Like there's not a whole
Exactly.
lot of things. It is a single rigid body that's contacting with surface geometry most of the time.
Yeah, exactly. Yeah. So it was actually, there's not a lot going on. Even though you have realistic physics, there's not a lot of objects doing those physics. So that, and then two other shortcuts I take. Well, one's a common shortcut for all physics engines, which is if an object stops moving for a short period of time, you just put it in sleep mode where it no longer is updating the contact resolution every frame. And so you're able to save a lot of time or say, well, this is not moving. I only wake it up if it hits something new, right? Something that's already awake. But so if two objects are sleeping, you can just ignore contacts between those two objects. So that's one optimization, but that's fairly common. One that is not common is I actually don't calculate moment of inertia correctly, because moment of inertia, to try to represent it accurately, physics engines use a 3x3 matrix of data. And the reason why, you can imagine if you have a really long metal rod, if you take that metal rod and you try to swing it, it's harder to swing side to side than it is if you take that rod and spin it in your hand, right? There's some axes in which it's easier to spin it than others.
Okay.
So that's moment of inertia. That's why I use a matrix. So that matrix could represent that attribute, that it's harder to spin in one axis than the other. But most objects in Portal, at least the most common one, the cube, you can actually get away with moment of inertia just being a single number for a cube, because there's no axis at which it's, well, maybe that's not entirely true. If you spin it from corner to corner, a sphere, definitely. Sure. There's only like a sphere, it's the same. But treating moment of inertia as a single number instead of a matrix I just said I'm going to try that and see how well the physics works in it. I mean, it's not noticeable. Nobody pointed out, hey, you're not using a matrix for moment of inertia. So it really would only show for longer objects, clearly. So
that actually brings me, I guess, to like one of the things I was really curious about, which is, different physics engines from game to game. Obviously, physics interactions are extremely finicky. I think everyone has had, a Bethesda title do some weird physics stuff to them or whatever. And so, when these are physics-based puzzles, I imagined, I want to know, I guess, whether getting the physics feel exactly right was like important for making any of the puzzles work, or whether you had to like, you're implementing physics, but there are particular properties of the source physics engine. Like, were you trying to chase any of those at any point?
So for the most part, just using the correct value for gravity, and then trying to match the same velocities as much as I could seemed to work pretty well. And then just adjusting numbers till it felt right, not necessarily to what they were using. I know, like at one point, I realized that in Portal they actually add a invisible platform in front of portals that are on walls. So that way, because if you go through a portal, you can kind of go out of the portal a little ways before you fall.
Okay.
And you make use of that in some test chambers. So I had to implement that to get a certain gap in test chamber, I think it was 10, where you have to put a portal appears on the wall, you put another one and you go through it, and you're able to kind of clear a small gap. And in order for me to do that without jumping to match the original game, I had to add that ledge. And once that ledge was in, it just worked. Right. So for the most part, it really wasn't a lot of tweaking, because I think, let's see, they followed regular paths. I checked in. I did do screen recordings of playing Portal, and they had the feature where you can turn on where it shows the position on the screen. So I was able to take that data, write down, like do a spreadsheet where I say, okay, here's the position that it tracked frame per frame, and then get a trajectory. And then I was like, okay, well, given this trajectory, this is how much acceleration it's getting. And I was able to kind of figure out, okay, well, I think that I have the correct values and matching that. So there was a little bit of that, but really, in terms of getting the physics to feel right, I mostly just, I was kind of winging it. Like another thing I had to do is, when a fast object like a cube, if it's moving really fast and hits a wall, or a button, actually in this case is where it's important, you want it to lose a lot of energy, because you don't want it bouncing off the button. You want it to fall, hit, and then just stay. So there's actually two modes of collision detection in Portal 64. One is for fast moving objects, and one is for objects that are already touching. So for fast moving objects, I use swept collision. So if you imagine you take the shape of the object. Let me see. You have the object where it started and then where it ended up, and then you draw a convex shape around both of those. And so now you have this long stretched object, and you do collision with that object against level geometry. So that way it can't tunnel through walls. And when I'm in that mode, after detecting a collision, I'm actually able to just say, okay, you hit here, and then I adjust the velocity as well when resolving that collision. So when a box hits a button, I cut its velocity so it ideally will stay on the button and not just bounce off.
Flying around.
Yeah.
Interesting. So I guess one kind of like a little physics detour. So, on your YouTube channel, which is great, by the way, you do some really, really wonderful explainer videos. You did a little bit of an exploration in tackling like a question about Portal, because Portal doesn't have, Portal 1 didn't have moving portals, right? And you wanted to resolve what happened in this case. Can you tell us briefly about that?
Yeah. So I was on Reddit, there's a discussion about what would happen with portals and with moving portals. And I just thought, it just surprised me how many people supported what I thought was, at least to me, seemed like the wrong answer. And so I'm like, this isn't right. I need to explain why moving portals would work the way they do.
Right.
And so I decided, well, I'm working on a portal physics engine. Let's just implement moving portals. And so I did, as a kind of a way to show, look, this is how it would work. And yeah, I mean, I feel like I did that video and then another follow-up video, and I feel like I pretty clearly explained my case, but there's still people who disagree. Just as a side note,
right?
When talking with Valve about whether or not we would continue the project, they'd let me continue the project. In that conversation, one of the guys who originally worked on Portal 1 was just telling me that he really thought the game was really cool and he was really impressed with it. And then he also chimed in and said, yeah, the Portal paradox, I've tried to explain to people why they would shoot out, and it's so anyway, I just want to point out one of the guy who originally worked on Portal 1 physics engine agrees that the cube would shoot out instead of stay stationary after coming out the other side.
Edit the thumbnail for that video and put a big like Valve stamp of approval on your
video.
Awesome. So we'll get to that conversation and what happened with Valve very shortly. But I guess before we move on to that, just while we're talking about the technical stuff, were there any, we've spoken a lot about the physics and other areas of implementation. That were there any other technical challenges that were particularly hard to overcome or that surprised you in going about this project?
There's one challenge with N64 is the resolution is so small.
Okay.
That details just really get mangled, especially really small things. And there are plenty of objects in Portal, like the radio antenna, for example. I had to make that thicker to get that to look right. And and then just generally the challenge of low resolution, I guess both in terms of the screen size, but also depth buffer resolution. There's a lot of Z fighting artifacts in Portal 64. I was making improvements. I was making things better there, but that was just kind of a limitation of the system. That and the fact that the graphics pipeline uses fixed point numbers for its 3D calculations, which limits the range quite a bit on what values you can use. And that was leading to some graphical issues in some of the larger test chambers with the portals. And so that was kind of a big constraint that I had. I always had to keep trying to adjust things to make it work within those constraints.
Awesome. Yeah, I guess the resolution must be particularly tricky as well when you're looking at things that are also through portals that are even tinier than otherwise, right?
Yes.
Yeah.
Yep.
Cool. Yeah. So, I mean, you mentioned a couple of times that Portal 64, you've had to take it down, and you mentioned you have a call with Valve. Can you run us briefly through that situation? Which I'm saying knowing that you have a very good YouTube video about this, so don't want to make your entire video, but a brief overview would be great.
Yeah. So somebody from Valve reached out and got in conversation with them about the project, and they were asking. So I was like, hey, I asked them, what could I do to officially get your permission to finish this project? Because I wanted to have. I mean, I was going to keep going until I was told to stop, but ideally, I just have their permission because then I wouldn't have to worry about that anymore, right? Like they could say, yeah, I'd be able to finish this project, and because like not knowing whether or not you'd finish, like I don't want to put another year or two into the project and have it stopped right before it was done. So I was talking with some of their lawyers, and they're asking me some questions about, okay, how is this rolled out? How do you distribute this to people? And then they asked the question, is there anything that Nintendo wouldn't like, basically? And unfortunately, the answer to that was, well, I'm using LibUltra, which is their proprietary SDK.
Mm-hmm.
Then when they heard that, they basically said, okay, yeah, we can't support it. And I'm sure it's, they have to cover their legal basis. Like it's if they had an internal conversation about whether or not, they would let me continue this project, and they say, yeah, sure, just if Nintendo gets mad, then we'll shut it down. Like I feel like that would be like a record that could go to court if Nintendo decided they wanted to sue Valve, right? They'd be, look, they let this person continue this project using our proprietary SDK, and well, maybe I'm not a big enough target for Nintendo. Valve certainly is.
Yeah.
So to Valve, that's like they're just not going to go there. And so I did a follow-up question, ask, okay, if I could port it to LibDragon, which a LibDragon is an open source, non-proprietary SDK for N64, would you let me continue it? And they discussed a little further. I'm not sure what was said there, but they came back and said that they don't really want to have to worry about monitoring this project, or like I'm sure basically it's just to them it's a liability and a cost potentially to track it.
Right.
So there's not really much benefit to them. So they're like, just to cover themselves because Nintendo's involved, they just said no, we're not gonna allow this project to continue. So, and I understand that. Like I figured, like it was a long shot, but I figured if this project were to be completed, it would require both Nintendo and Valve agreeing to it,
Sure.
which would be a harder sell than just a single one of those companies.
Yeah, absolutely.
So.
Yeah. So I guess, seeing that whole situation, and also, seeing it's not an uncommon situation, particularly, Nintendo have a bit of a reputation for this kind of thing. And, hearing mainly from you that these N64 jams are, such a common thing. I guess, one thing I wanted to ask you, as both an N64, hacker, but also someone who's in that community, like, how do you approach, being creative and being a developer on these consoles with that kind of always looming threat that, the work will last a little bit and then might have to disappear for whatever reason?
Right. Well, I like getting the work done. I like people being able to play the ROMs and the things I make. That's definitely part of it. But I feel like just the process of creating is a lot of fun, and sharing it with people and them being able to see it is part of the fun. So I mean, ideally it'd be great to have a final product that I could distribute freely and not have to worry about that. But I think the process and kind of the exploration is part of the fun for sure.
Very cool. And this, I imagine, is a bit of a tricky question to answer. But, if there are people listening to this who are like, I want to have a go at developing on the N64, but I am scared of, someone coming after me. Do you have any, like, what are the obvious things that people can do to avoid falling foul of trouble? And I imagine LibDragon is a good place to start, rather than using LibUltra.
Exactly. Yeah. If you want to make N64 games and have any chance at being able to be successful and maybe even potentially monetizing, like selling, LibDragon. You want to use LibDragon. That's not it's not Nintendo's proprietary code. And then be sure that you're not using any Nintendo branding. So like is nice as it would be to have the N64 logo, pop up when you start a game. Like unless you want to try to lay low and just hope Nintendo doesn't crush it, don't do that. Don't put Nintendo branding on any boxes or cartridges. Make sure it's free from any of that branding. Use LibUltra, and I think as not legal advice, I think that those are just things you can do to I think best avoid Nintendo's ire. But because I know people have sold commercial games, aftermarket games for NES,
Mhm.
and they've succeeded there. And I think it's just as long as you avoid the branding,
Right.
I think you'll be in the clear.
Mhm.
So that's that'd be
I
my
think
advice there.
GB Studio, like the community around GB Studio of making Game Boy games, there's definitely been commercial games for the Game Boy from GB Studio as well. So there's definitely
Yeah. Which
yeah.
the Game Boy, the bit of a tangent. That's a very interesting example, because I think the Nintendo came with a pretty clever way to protect against copies or unlicensed games, in which when you put the game in and you boot it, and that Game Boy logo that shows up, that's actually part of the copy protection, because the way they have it set up is the Game Boy first runs some code that's supposed to display the Game Boy logo, and it tries to check if it's not the Game Boy logo, we won't boot the game.
Wow.
So that was their copy protection, and the idea is if you create an unlicensed game, well, you have to show the Game Boy trademark, so they'd be able to go after you legally, right? Because that was a requirement to get it to boot. Well, hackers have since figured out ways to get around that, where you can show some other logo that's not Game Boy and still have it boot.
Hash or whatever, right?
So yeah,
It's
that was their way they got around that.
it's so these methods are so ingenious and so technically cool. It's just such a shame the category of like thing they are doing with that.
Right. Well, yeah.
Yeah, that's really interesting.
Hmm.
Um, cool. Yeah, that I think again heavily not legal advice, but it is knowing about there is a non-proprietary SDK out there is I
Hmm.
think super helpful. And you mentioned some of the game jams that you got your start in. Is there any particular events or like communities that you would point people to get started if they were looking to do that?
Yeah, there's an N64 Brew Discord server.
Cool.
That's where I jumped in to get started, and a lot of great resources there. And there's, I mean, that Discord server alone is going to have it has a page where a bunch of links where you can get started, and
Cool.
people create like open source tools to like compile assets to run on N64, and yeah, really, I think that'd be a good place to start.
Awesome. And I guess the last question I have for you, well, almost last, I've got a bit of personal curiosity as well. Are there any developers who are making N64 content or content creators that you'd recommend that folks check out?
I mean, there's obviously K's. If you're familiar with me, you're probably familiar with K's. He's doing really cool stuff, modding Mario 64.
So many more.
Um, I don't know of anything that's like you could go see on YouTube. I mean, there's the Smash Remix project, which they're adding new characters to Super Smash Brothers 64, which it's just I'm wildly impressed with that project. That one's really cool.
The Super Smash
Um,
community, like across the generations, is unhinged and very impressive to me. Like the Melee community, especially. I'm in awe at every level of Smash community. They're so dedicated to that game.
oh yeah, yeah. So that's a great project, and I know, like I've seen on the Discord server, I'm seeing people. Somebody's trying to demake Five Nights at Freddy's for N64. Um, there's an occasion that you just see people posting updates from their own personal projects, their own original games, and there's a few that are making some pretty cool progress
Yeah.
on that you'll see on the Discord server. I don't know if they're I don't know of any places to send you to actually test it or to see the project, but I'm certainly if any of those projects do finish and they release, I'll probably give a shout out on my channel to them, because I mean they're very very impressive projects to be doing solo developer. So
Awesome. But in the meantime, the N64 Brew Discord is the place to hear about them.
yeah, that's what I would recommend.
Awesome. And then, yeah, my one bit of curiosity, and I've been wondering this since watching your YouTube videos. What
Mhm.
is the red console behind you? Is that a Wii U
Oh
or is
no,
that a modded Switch, right?
it's let me grab it. So it's actually an
N64.
N64 portable.
Wow, okay.
Yeah.
Cool.
So like
Yeah, as it came towards the camera, suddenly I was like, that is bigger than I thought it was.
yeah, oh it is. Yeah. It's
Yeah.
been a while since I fired it up.
So for folks
So
listening, this is like if you imagine a Steam Deck sized device. Well, a Steam Deck looking device, but it is an entire N64.
quite large.
Incredible.
Battery's dead, so I
Yeah.
won't be able to
Yeah.
fire it up. But yeah, so it's a this is actually I made this around the time I started getting the brew development,
Right.
which is it's yeah, it's kind of janky in a lot of ways. You'll notice that the body's made out of wood, because I didn't have a good 3D printer at the time.
Yeah. No, I think
So
making it out of wood is awesome. That's like bring back wooden handhelds.
yeah,
I realized, having seen you bring out a piece of hardware that you've been working on, I forgot to ask a very important question. Now that Port 64 is offline, what are you working on next?
right. So there's still a few ideas for just tinkering with N64 hardware that I'm working on. Like right now, I am trying to get the Oculus DK1 to work on N64, so you'll be able to play a virtual reality game on N64. I'll probably have a few other random ideas like that, but I am starting a new game project.
Mm-hmm.
I still in the early phases of just kind of making ideas and getting kind of the foundation set up. Since I'm using LiveDragon, I kind of have to rewrite a lot of engine code. I'm not just going to be able to have a good starting point like I do for my LiveDragon or sorry, Live Ultra
Yeah.
based game projects. So it's it still may be a few months before I even have like a really basic prototype to show. But yeah, I'm starting on a new game project there.
Awesome. Cool. Well, James, thank you so much. I've definitely learned a lot, and I'm sure our viewers and listeners have as well. Thank you so much for joining me today.
So, thank you.